Y sin más precedentes, vamos a por el plato fuerte de la jornada. Plato fuerte de la jornada que vendrá presentado por Maite Ardèvol, que es Sustainable Circular Economy and Sustainable Lead de ACCIÓ. Maite, cuando quieras, ya puedes empezar con tu introducción a una jornada que está repleta de conocimiento. Gracias, Maite.
Gracias, Pilar. For having ACCIÓ here today. It's a pleasure to be part of this circular economy track that gathers one of the key sectors to make transition to circular economy a reality. In fact, chemical sector is also one of the leading industrial sectors in Catalonia, in Spain. It's highly dynamic, international, and innovative. And so he has the key assets for a circular economy transformation. And it's really an honor to introduce you, Mr. Walter Stahel. He's the father of circular economy and economy in loops. Their research for almost 20 years is absolutely fundamental in the development of this vision, of this alternative economic model. He was pioneer sketching the vision for circular economy and its impact on job creation and economic competitiveness. In their 1976 research report to the European Commission, about the potential for substituting manpower for energy, for example. And also, his research and book on the performance economy also anticipates on how exponential digital technology revolution is a great opportunity for this economy that sells function, service instead of goods or products. And his latest books, The Circular Economy, a User Guide, that sum up all this work and explore the circular economy under two major visions: the era of reuse, remanufacture, and repair, and the era of de-polymerize, de-bonding, de-alloy, or in other words, the era of management of stocks of molecules, what sure is relevant for the audience of this session. And again, Mr. Stahel, it's a pleasure to have you with us, and the screen is yours.
Thank you very much, Maite Ardèvol. So I shall show you a couple of slides. Just have to find my way into the okay, well, miracles take longer sometimes.
Sure.
Okay, so sorry about that. I'm going to talk about circular economy opportunities, especially for the chemical industries. But let's start with the origins of circularity was, of course, nature and poverty, scarcity, good husbandry, and then infrastructure. Roman aqueducts have lasted for 2000 years. But a modern circular economy in the modern world, we have to look at the whole economy as a bathtub. And then you have the water inflow, which is the linear industrial economy, production, which we measure in great detail. You have the stock, quality and quantity of the stock of water, which is the circular and performance economy. And finally, you have the outflow that we don't really measure very precisely, and we treat it as waste management. So we have basically two industrial economy models. One is the linear manufacturing economy, but that ends in waste, and the waste is managed by states. And at the bottom, you have performance economy that covers the whole spectrum, and you have the circular economy that covers the use of products and materials. A big difference between the linear economy and the circular economy is the point of sale, because the circular economy has no point of sale, so you don't see it. So all the lovely things you see on this slide are part of the linear industrial economy, but they are not part of the circular economy. A second difference is depreciated value. In the linear economy, so if you smash up something that is more than 100 years old, it has been depreciated a long time ago, which means it has, economically speaking, no value. Whereas in the circular economy, it's the use value or functional value that is, of course, for the statue still there. So the circular economy is about stocks. And we are here especially looking at manufactured capital, materials, and objects. The circular economy is about economics, innovation, and competitiveness. And I'll take you through these, at least the first 4 or 5 of these items here. But the origin of the circular economy, the industrial circular economy, goes back to my study in 1976 that used this slide here, because there is basically 2 domains. One is the reuse of objects, and the other one through repair, reuse, remanufacture, and the other one is the reuse of base materials or the recycling loop. And the 2 are separated by the profit barrier. The one on the right is normally profitable, the one on the left is normally not profitable. But in a forward-looking, the view of a mature circular industrial economy in the future, you will see has the same two main domains. One is product use, the circular user economy, maintaining value and utility. The other one is the area of D, which is the end of life products that need to be turned into new resources as good as new. Why is the circular economy important? This is a study done on half a dozen European countries, and in every case, the analysis showed that a transfer to a circular economy will reduce greenhouse gases by 66%, create about 4% additional jobs, and have a positive trade balance. So the main thing is the societal benefits. And this is the driver of the circular economy, why the European Union now is adopting it as main strategy. But let's first look at the area of R, which Maite has already mentioned. And the important thing is here, the owner users of the objects, you and me, are in control to maintain the value and utility of stocks by extending service life with, again, the result that has already been shown in the study before. The area of R is easy because ownership, value, and liability are in one hand. And so therefore, managing it is open to everybody. One of the reasons why I always stress the shift to a circular economy, it creates local skilled jobs. And this is my now 51-year-old Toyota when it was 30 years old. And you can see that the longer you use a product, the more the expenses shift from the factory to local labor. And so it's creating local jobs. the area of R in chemistry, why you should be interested. It opens new opportunities for innovative chemicals to optimize the use phase of the stock of objects. You have several examples here: buildings, maintenance and cleaning, equipment remanufacture, innovative repairs. Let's look at these. Spino is the world leader in rail grinding, which is in situ remanufacturing of rail heads instead of replacing the rails. The quality of the ground rails is 10 times better than a new rail at half the cost. But one of the key things, obviously, is the grinding stones, because these are the wearing elements, and without that, the whole thing doesn't work. Why remanufacturing of trains, for example, makes sense? You can see that the cost is 87% cheaper than to buy an equivalent new train, and the resource savings and the CO2 emission savings are all given here. You will get the slides afterwards, I suppose, so don't have to panic when you can't read everything. And this is done locally. And it needs, of course, special chemicals for taking it apart, cleaning the structure and rebuilding it. Circular society is something that is very regional or local. In Japan, they use the golden sewing, which is a glue with gold in it that you see on the right. And that makes the broken object that is now repaired much more vulnerable, much more unique than the not broken objects. And again, who takes the decisions in this area of R? It's you, the owner user. The area of D is a legacy from the Anthropocene. It's to maintain the value and purity of elements, atoms, molecules by recovering pure molecules. So we need technologies to de-polymerize. We have some there. De-alloy, delaminate. You have the whole list. And this implies non-mixed collection methods, disassembly and non-destructive maximum value recovery processes, and then, of course, technologies to recover the atoms. So the objective is to maintain the value and purity of materials. Now, if you look, this is a Swedish study. If you look at the material value versus the recycling success for plastic, you will see that in Swedish recycling statistics show you that 53% of the plastics are recycled. But if you look at the value retained, it's only 8%. So of the original value. So it may be efficient as a waste management strategy. It's not efficient in a circular economy. So the area of D has the problem that ownership is clear, but value and liability are not. Chemistry is a child of the Anthropocene, basically after World War II, when these applications exploded. But these man-made or synthetic materials also impose a man-made responsibility, this area of D, which we have neglected for a long time. So what do we do with windmill blades? This is a cemetery from the US. It's carbon fiber laminates, but we don't know how to delaminate them, how to recover the plastics and the carbon fibers or glass fibers. So we bury it, we give it a funeral. They will last forever, but that's the end of the linear industrial economy. That is not a circular economy. In recycling, we are very proud if we recycle for aluminum cans 50% or even 75% in some cases, or 90%. But as a Coke can, for example, has a life of only 3 weeks, you lose, if you take the 50% recycling rate, you lose 50% every 3 weeks. So after half a year, you have lost your aluminum, the stock of aluminum. So don't look at the rate of one recycling loop. Look at the rate over a whole year. Similarly, if you look at nickel in metallurgy, every time you recycle a nickel alloy, you lose part of the nickel. So why should you be interested in the area of chemistry? There's a lot of new opportunities in innovative technologies and methods to recover atoms and molecules. Of course, these are different methods from manufacturing the same molecules very often. And there are completely novel things, such as a method of converting mixed plastic waste into hydrogen gas and solid carbon. This is tested in some universities, it works. And so you can actually strip hydrogen from the polymers, and hydrogen, of course, is a clean, so-called clean carbon-free fuel. Process innovation is also needed to convert wastewater into drinking water. Singapore is the only state, I think, that has achieved this so far. Or to recover phosphorus from wastewater treatment plants. This is something we do in Switzerland together with 20 other nanopollutants. Innovation in systems, materials, components, to upgrade stocks and to produce new materials, material sciences, for productive industries. So it goes, these innovations go into production and into existing products. Here you have a couple of circular chemistry examples. Convert end-of-life tires into liquid hydrocarbons, carbon black. You can go through the whole list, a lot of bacterial enzymes. So we are talking about the mix of biology, chemistry, engineering. We need new brains that are no longer experts only in chemistry to develop the new chemistry. And at the bottom, you have the carbon capture and utilization. If we can, or where we can replace petrochemistry with carbon chemistry, then of course we have achieved the zero carbon objective. This is one PDK, is one intelligent plastic designed for chemical circularity that will go round and round as long as we recover, of course, the polymer. Circular energy examples. Think of green hydrogen made from green energy, ammonium, iron powder, geothermal, concepts such as integrated energy management systems. There are a lot of opportunities that are all being researched, and the political power is that Japan, Norway, Shell have already started switching or have already switched to green hydrogen. Germany and the EU want to follow suit. So these things are happening. Circular metallurgy examples is not really linked to chemistry, but it's also interesting that even metallurgy starts to follow completely new tracks. For example, to use iron powder as a new circular fuel. This has started last week in the Netherlands, and it works. Never thought about iron power as a clean and wasteless energy, did you? So spreading the knowledge of the circular economy to classrooms and boardrooms, parliaments is key, because it's only once everybody is familiar with this that it will really move. Policy challenges include taxation, include a full producer liability. So even as a chemical company, you may become liable for what you have produced. And here the big driver is the public procurement starts to prefer circular economy to new products. So innovative policymaking is closing, among other things, closing this liability loop, returning objects and materials to the producer. But circular economy is also part of a new trend of intelligent decentralization. Microbreweries and microbakeries, microcredit, micro insurance and farming. But let's look at the additive manufacturing, local energy production, medicine on demand is one that is probably not very well known. This was in Nature a couple of months ago. It's basically miniature production facilities that fit into a briefcase. Just a short publicity, that's the Spanish book, and that's the English book that Maite mentioned. But now performance economy, where again the owner managers are in control. In other words, owner value and liability are in one hand. And here you have the different business models of the performance economy. The one that is especially relevant for chemicals is selling performance. In the agriculture, that means selling agricultural management services or molecules, chemicals as a service instead of selling chemicals. It's clear that the liability, the value is very different from selling chemicals to farmers. But one of the advantages, you can do more with less, and you have a toxic release inventory. You know where things have been spent. Selling performance is also starting for expensive pharmaceuticals, for example, used in oncology. I think Novartis, without naming anybody, is one of the companies that now for the very expensive medication reimburses the client if the treating doctor, medical doctor, realizes that the medication did not provide the promised result. So the performance economy will, even in chemicals, I think, become more and more important. It's pushed. Rent molecule is pushed by UNIDO in Africa because not only the application of the chemicals is more intelligent, but also the spent chemicals and all the containers, the packaging, have to be returned to the manufacturer. Because one of the big health problems in Africa is that people use these containers from toxic chemicals afterwards to store drinking water. And selling materials as a service opens completely new avenues, such as this reusable composite powder developed by the UK Cookson Group that is an extremely powerful permanent magnet. It can be pressed into any form and it can be ground, and you get back the powder and can remix it for next use. But of course, the manufacturer wants to keep control. He wants to harvest the benefits from this, and he will not sell it. He will only lease it to component manufacturers such as battery or electric motor manufacturers. Molecules as a service comes on and off for solvents. SafeChem, for example, division of Dow. Lubrication oils, Castrol division of BP has tried it. It works, but it always enters into conflict with the linear industrial economy. Then there are business models beyond catalytic chemicals. License to mine, metal leasing is something that would completely revolutionize the mining industry and the way we use metals, mostly in this case. Now, if you think this is revolutionary, you have forgotten to read Aristotle, because he said real wealth is based on use, not ownership. So the circular economy puts the use of materials and objects in the center of the economy. And to summarize, I talked about the era of R, as in reuse, repair, product use, the area of D, delinking materials to recover atoms and molecules as pure as new, and then the innovative new materials, component systems, where I've only been able to give you a few examples because a lot of the innovations are happening in universities and in companies. And of course, it's really about competitiveness. Innovation to be number one, to be more competitive. So you not always can cite or give the details. Thank you very much for listening.
Thanks, Mr. Stahel, for this clear, brilliant, and inspiring speech. It has been plenty of examples of opportunities and circular economy examples for chemistry. In the meanwhile, we receive questions from the audience. I would like to pose the first one. You mentioned that circular economy is an opportunity for job creation. Could you expand on that? It's an opportunity for skill jobs as well?
Yes, I've shown you the slide from my car after 30 years. But the job creation is in the area of R, because if you disassemble a car or an engine, whatever, an equipment, you first need a lot of work just to disassemble the equipment. Then you have to clean it, and then you need a qualitative judgment, because you want to do the least work necessary. So you have to be able to identify which are the components that you can repair, which are the components that you can reuse, which are the components that you can remanufacture or have to replace, and then you have to reassemble the whole thing. And this obviously is much more labor intensive than using robots to build a new engine or a new car.
Okay.
And you have to do it locally.
Yeah,
the area of R is always locally.
Good. Some other questions from the audience. Which are the most important contribution of PVC related to circular economy?
Well, PVC.
We can ask for plastics in general, if you want.
Yeah, no, well,
or
okay,
both.
Let's take plastics is a fantastic material. You can produce almost any color, any shape you want. But plastic is a man-made material. It's not compatible with nature. Nature doesn't know what to do with it. And so it's in our responsibility that if we use plastic objects, that we don't let it escape into the environment. It's our responsibility to put it back into recycling or incineration, which is recovering the energy. But if you plastic elements that escape into the environment, then we have a huge problem. And of course, where you have microplastics such as tire wear, polyurethane from vehicle tires, then we have a problem that is almost beyond our control, because we don't know how to prevent these nanoplastics to go into the fields and the water and the rivers.
Yeah.
But plastics are a fantastic material, but we have to learn. It's our responsibility to learn how to keep them under control.
Okay. There is another question related. Instead of promoting a circular economy, which should also be done, wouldn't it be better to find any way to make the production of materials, I think it means easy to recycle?
Yes, this is what I said with the circular chemistry sciences. There's a lot of research going on how to make new monomers that then can be polymerized and de-polymerized. Today you can do that with polyamide 6 and 66 with nylon. There are several ways to de-polymerize it and reuse it. There's a lot of companies that are doing it in carpet manufacturing, for example. But the thing is really, if we can produce plastics that no longer become waste, but that really can be, or otherwise that can be, we also have to learn what to do with the legacy waste of used plastics today, the mixed plastic waste. And this process I mentioned of transforming it into hydrogen and carbon black, I think that is a very promising road, because then it makes the collection and cleaning almost the cleaning superfluous, but the collection much easier.
Yeah, it's really an incredible opportunity. And related to this last one about about de-polymerization. This is a question that is asking that the technology is efficient from the energy point of view. This converting, for example, the mix of plastic in hydrogen. There is a risk to spend too much energy in the process?
I don't think so, because it's new processes. So you don't very often use enzymes. You use all kind of novel things, and you don't go through the traditional chemical processes.
Okay.
And that's one reason. And the other reason, of course, this is a very novel thing. And as always, in the beginning, we are very inefficient. And by doing it, then we learn how to improve it and become better and better. So you have to be very careful if you compare a process that has existed for 100 years with a process that is 1 year old, because their efficiencies cannot be compared. Yeah, so you need a bit of patience.
Good. I would like to pose another questions regarding why performance economy delivers more value to companies, but mainly what are the challenges for business as also for the chemical industry to put into practice? You mentioned, for example, that it's necessary a new way of taxation of renewable resources. You mentioned also about liability and risk and management, this liability. So could you expand on that a little bit?
Yes, the performance economy maintains ownership, and which means that automatically you will recycle, reuse, polymerize, or you will use all the tricks to make the materials you have last for the longest period of time. And that means you save transaction costs because there is no change in ownership, and you save the cost of proving every time that there is no child labor involved, there is no conflict minerals involved, because it's your material. And so the stronger or the stricter these legislation gets to prove that you are not harming the environment or violating human rights, the cheaper it gets to stick to the materials you have and reuse them. A lot of, for example, Rolls-Royce, General Electric, the turbine jet engine manufacturers already do this for another reason, because they use a lot of rare elements, rare metals. And in order to make sure that they never have a short supply, they keep the ownership of these metals, and they are reusing them. So they use recycling as a service, but the important thing is really, as long as you maintain ownership and liability, you also get the benefits for maintaining the value.
Okay. Another question will be related, well, you have put many examples of opportunities for chemical sectors, and examples that are put us in another vision of the future. But in this sense, what could be new innovation fields for chemical sector that could make a greater contribution to circular economy? You mentioned plastics to energy. There is another field that could also help us.
I think the biggest, but that's mostly done now in universities, is the carbon capture and utilization. So because then we take the carbon, the CO2 emissions out of the atmosphere or out of chimney flues from power stations, and we reduce the CO2 emissions, and then we use the CO2 to produce carbon black, to produce different chemicals. That's something that is at the very beginning, but there is a lot of the top universities, MIT, ETH Zurich, are in this CCU consortium. And you know, there's always, for any researcher, the top is always the Nobel Prize. And whoever can solve this kind of problem is almost assured to get a Nobel Prize. So there, it's not the money, it's not the, it's really what drives researchers is to be the first to fundamentally solve a problem.
There is a question related with that. There's another question. Do you see, from the audience, do you see a prospect in CO2 recycling technologies in European industry? Well, I think you have already answered. Do you believe that it will be shorter, the time that we could see that research in practice?
It's already being done in normally it's startup companies that are linked to big universities. Again, the Swiss Federal Institute of Technology in Zurich, ETH Zurich, is one that already has, I think, half a dozen startups. It's done, but it's done on a pilot basis. So the thing is now to scale it up to industrial, but it can be done. It makes sense. And of course, as soon as we really get the carbon tax, then by doing that, you get basically a subsidy from the state, from this carbon tax.
You have the
so even if the process is not in itself financially viable, but you get money for taking CO2 out of the atmosphere.
So you have also the economic motivation. So, what is needed to change to have a circular economy in practice at global scale? Because it's not the same, the reality that we live in industrialized countries that in the countries that are developing. So what are your thoughts about that?
Well, in many less developed regions, people already live in a circular economy. But as I said in the beginning, it's a circular economy of scarcity, of poverty. And so the problem is in the societies of affluence, in highly developed industrialized countries, we need to develop the motivation, find the behavioral sciences. How can we motivate people not to consume? Because in a society of affluence, by definition, you basically have already everything you need. You just have to make the things that you have, make them last, and learn to love them. Because anything that you have any object that you have a personal relationship with, as my car, or I have a 60-year-old wristwatch and things like this, you don't throw away, you don't replace it, even if a new one comes out and is in publicity, tells you this is the latest thing. No, I have a car. I don't need a new car, thank you, or a new watch. So it's really a mental problem. The owner user has to learn to appreciate what he has and enjoy the use of it, and then take care of the belongings, have them repaired, or give them away to somebody if you don't need them anymore. It's in our mind. It's not the technology. It's in our behavior and our minds.
Okay. So there is another question regarding to petrochemicals. from the audience, what is better approach to get drop in chemicals or dedicated products as biolubricants, bioadditives, etc.?
Well, the whole biomethane, for example, in energy, or bioplastics, we just have to be careful. There are also some plastics have been developed that disintegrate after a certain time. We have to be very careful that, for example, for sterile equipment in hospitals, that we use plastics that guarantee that even after 10 years, these equipment, these instruments are still sterile. So I think there is different applications for different plastics, and there will always be the traditional plastics will always have a place. And for other applications, there will be, we can use Stark. Stark is a bioplastic. Again, there are many of these things are on the market, but don't forget that if you have a diverse production, you lose the economy of scale. And so therefore, what industry hates most is to suddenly have products that get more expensive. And so therefore, it's easier to produce huge volumes of one type of material than 100 small volumes of 100 different materials. And I think this is, in the end, it's, as I said, it's about innovation, about competitiveness and economics. Circular economy is about economics. And we have to find solutions that are economically viable. Otherwise, they don't survive.
That will be the main incentive to change. So let me ask you a final questions. Are you optimistic about the future? What are your thoughts about circular future after COVID-19?
I'm very optimistic for the future, because when I did the first study in 1976 for the European Commission, people thought I was crazy. For 10 years, the Commission didn't even accept the results of the study because it was so way out of mainstream economics. Today, most countries are developing a national circular economy plan, even countries like Indonesia and the Philippines. So the fact that a circular economy is there and offers opportunities has now been established. Now, the problem is, how do we apply it, and how can we show that today's industry or today's economy will not break down in the transfer? And it's a bit like the car industry. If we move to electric mobility, we know that the whole industry of producing combustion engines is doomed, and huge investments. And electric mobility, I think the battery road is the wrong road, because we can't solve the waste problem. Whereas the hydrogen road is zero carbon and small waste. And not only electric mobility, but in Sweden, the whole steel industry is now switching to using hydrogen instead of using coal. So there will be big changes with a lot of stranded capital and technology locked in. But again, those who survive will be those that change first. And I keep telling people, if you want to look to be still present as a company in 50 years' time, the circular economy will still be there in 50 years' time. The linear industrial economy will probably have disappeared. The performance economy will, because it integrates liability and all the environmental impairment, will probably win because the economic actor accepts full responsibility, full liability for what he's doing and for his products and the end of life of their products. And this is something that is mostly missing today, but the social pressure will push for it more than the financial pressures.
You think so? Do you think that we are in the right speed of transition, or we need to accelerate, or we are too late?
No, I think you're in Europe, we don't realize that we are not alone in the world. And China, for example, has in its economic development plan 5 pillars. And one of these pillars is remanufacturing. In the United States, industrial remanufacturing has existed for the last 50 years. Actually, Pearl Harbor was the first example when they realized that if you can't rebuild new ships, then at least you can remanufacture the sunken ships. And in Europe, we still don't really. There are some examples. There is SKF, the ball bearings, the bearings industry. They take back, but in remanufacturing, the missing link at the moment is the people who have the end-of-life goods don't know how to give them back, and the people who are doing the remanufacturing very often don't know where to find the cores, where to find the used elements. So we have to develop a market for many of these applications of the circular economy.
Okay. So, and imagine that, for example, digital technologies could help on that. For example, yes. 3D printing for spare parts with appropriate material can be a solution to spread remanufacturing, or to easier repairing and remanufacturing, for example.
Yes, all this, what I call the intelligent decentralization, robots, the 3D printing, and of course data banks, data exchanges, digital markets, all these things are not yet widely used in the circular economy, but except the remanufacturing of IT hardware. But again, there's a lot of hungry young people out there that are looking for a start, how to do a startup, where can I get a market, where can I do something. And I think these young people that are very often no longer formed in only one discipline, but have a much broader education and experience, I think the young people will save the world, not people like me.
Good. We have run out of time. We need to close the session. I hope you all have enjoyed the conversation, and it could help to have a more clear vision on how we can contribute to this circular economy transformation. Just to conclude, as Mr. Stahel mentioned, to say that innovation and technology development in chemical sector is crucial for setting up the speed for circular economy agenda. It's also essential to bring new circular economy solutions in many directions. And as Mr. Stahel pointed, making debounding possible in an efficient way making compounding or recombining resources for materials that enables upcycling or longer useful life, adding new properties, of facilitating the repairing and remanufacturing with the appropriate materials for spare part, for 3D printing, as many other examples and possible solutions where chemical industry has the key for closing loops. So thanks again, Mr. Stahel.
Thank you very much, Maite.
And thanks all the attendants, and see you on next upcoming sessions. Thanks for joining today.
Okay, thank you very much, Maite. Thank you very much, Professor Stahel.
Thank you
for having this kind of learnings in order to speak a little bit more the industry, the chemical industry, in the right way. Okay, this is not a planet B. This is a planet A. That's our main topic. Thanks a lot for all that. And well, to the audience, thanks a lot also to be here. And when I change to language right now, muchas gracias a todos por participar, por estar aquí. Gracias a los presidentes por haber hecho esta sesión inaugural, a Maite y al profesor Stahel por sus conocimientos sobre uno de los ejes más importantes de este Unprecedented Virtual Forum, que es el eje de la circularidad, de la Circular Economy. Y nada, os esperamos, os animamos en las siguientes sesiones. Tenemos una semana llena de conocimiento, de transferencia, de tecnología. En breve, en media hora, tenemos la presentación del estudio de genómica por parte también de los compañeros de ACCIÓ, dando nuevas posibilidades, dando nuevas pistas a este desarrollo, un desarrollo, como comentaba el profesor Stahel, que es totalmente circular porque es totalmente integral. Con lo cual, bienvenidos a esta íntegra semana para que realmente aprendamos todos. Muchísimas gracias por todos. Nos vemos en breve.
Thank you.